Hey everybody, this is Mike Guthrie here. I'm just going to do a quick introduction to how you can improve and protect your monitoring leveraging Ziti. And before I go into that, we'll kind of cover how people are typically doing their infrastructure monitoring, both how they've done it in the past and kind of what is emerging as kind of the common practice most places, and just so you can kind of get an idea for where data is flowing, where network connectivity is required, and where security issues can come up, as well as access issues. So with this diagram that you're seeing here, this is taking a look at kind of a modern example of how a lot of people are doing their monitoring within their infrastructure, whether it be in a cloud provider, in a private data center, Kubernetes, and so forth. And this is just kind of I left it pretty generic on purpose, just because it's a common model that'll apply for just about anybody, whether they're in a private DC space or in cloud space. But most modern monitoring is built all around kind of a data collection model, to where you have kind of a central data store that acts basically as just kind of like a garbage pail of data. It's your data lake. And it can, it can be your ingest point for logs, for metric data, you name it, any type of system information that's useful to detect problems. And it's a central place. And then once all of the data is in there, there'll be some sort of like a query engine that runs against that data store that basically asks, hey, is there anything with, CPU usage over 80%? Is there anything with, certain critical error that's showing, and so forth? There'll basically be some sort of a query engine that's running against that. And you'll get that with, a Datadog or a Prometheus, Sensu. A lot of the more modern monitoring tools are using this type of approach. And the way that they get all the data to this central place is that typically you'll have all of your nodes out in the wild, whether they be VMs, laptops, containers, you name it. A lot of basically most of the monitoring technologies, they'll have some sort of a collection agent. So in this diagram, I just label it as a collector. And this is typically software that you'll either install on that specific host, or it might be something that you run as like a sidecar container, that if you have a container-based application, you might place a collection container right next to it, and it has the ability to retrieve information from the other container. So, but let's just, for the purposes of this diagram, let's just say that you have a collector. Now, with a model like this, the idea is that you've got kind of collectors all over the place, and they are all shipping to a central point of ingest. A common issue that you've got with this is that you basically, you might have like a common set of credentials across all of these, or there's various ways of making this somewhat protected. Whether it be, a common set of credentials, you might have individual based credentials for each node, and so forth. It might issue certificates and things like that. But a key thing to note is that your point of ingest, it has to be public in order for this model to work. And you have to basically leave it open to the internet. If you're in like a multi-cloud type of situation, or you're going across VPCs, or you've got multiple data centers, things like that, this model is problematic for some people, to where they have concerns about shipping their data out across the internet to a central place. The other thing would be some places will have, they need to keep their outbound firewall rules pretty restricted. You need to punch holes in that and so forth in order for this collection agent to ship outward as well. The other place where this model is becoming common is, really, you'll see it anywhere, whether it's an IoT device. They have to talk to some public endpoint to retrieve data, retrieve upgrades, things like that. They all got to punch out, talk to something that is publicly exposed on the internet. And you'll see that, whether it's an antivirus software. Another one I've seen it is endpoint security. If you've got some sort of an endpoint security software, you're going to have a data collector on a node. In order to make that useful by a product, they're going to have to basically ship that to a somewhat central location. this is creating a challenge for a lot of people, whether they're using a monitoring tool or where they're actually building a product where they need to get data from all these disparate systems and then get it back to a central place. It creates a security challenge to where how do you get all the data from all these different places to a central location without having a public endpoint that's simply exposed over the internet that somebody can DDoS or try to exploit and so forth. It's a challenge that a lot of people are facing right now. And how do you deal with that? How do you make it secure? How do you lock it down and make it tighter? So enter in with, you know, a potential model that can be used leveraging Ziti. What's nice with Ziti is that this model works whether you're using an app embedded solution or if you're using a tunneler based solution with Ziti. The key idea with this is that your central data store that has all of your critical data, you don't have to expose a public point of ingest that somebody can pummel and DDoS or exploit at all. You basically can close down your point of ingress. I'm sorry, your point of ingress entirely to where you might have like a bank of edge routers helping to kind of float that traffic and disperse it. But basically, these edge routers, they're just dialed into the public fabric and so forth. But the collectors over here, instead of sending to a central public endpoint, they can actually send to an endpoint that's protected by Ziti. The intercept kicks in, and then it's a secure tunnel through the fabric all the way back to the central data store. And there's no point to where that traffic can be intercepted, and there's no point to where a public endpoint can be DDoSed and exposed. Depending on the setup as well, it can also potentially help with you know, in terms of outbound firewall restrictions, things like that. It can potentially help with that as well, depending on the setup that is implemented. But this is basically a way to kind of help protect your monitoring data to where it is secure from the collection point all the way to the central data store. There's no place where that can be intercepted, and there's no place a public API can be DDoSed by anybody. Let me see if I covered everything with that. The other place where this presents an interesting opportunity is companies that are actually developing data collectors like this, because that's kind of a known pain point, is having a central collection point just somewhere out on the internet that everything's sending to. Especially if you get into like the emerging security space where people are collecting a lot of really rich data from the endpoint itself to determine is it compromised and so forth. A lot of them are having to put a data store where it's like, here, we'll give you a deployable data store, but you have to put it inside of this private data center. Because of course, everybody's freaking out about the idea of collecting really sensitive data and shipping it right over the internet. But if it's a technology that actually is creating collectors and storing that data and analyzing it, think antivirus, think endpoint security, you name it. If you're a company that requires you to have some sort of a collection agent, being able to securely ship that over a secure tunnel to where you're not having to create a public endpoint, and you're not exposing that data and making it available for intercept. It's a really interesting value proposition to be able to have this secure tunneling just right over the internet, but you remove the point of intercept. So just something else to think about, and just another possible solution somebody could use Ziti in this space.